All right, guys, so now let's look at geometric series. We talked about sequences last time. So I've checked. Seems like the audio is worse with my AirPods, so I'm just going like this. Hope it doesn't suck too much. All right, geometric series is the sum of the geometric sequence. And we got a formula just like arithmetic, very, very similar here. S sub n is equal to a1 times 1 minus r to the n over 1 minus r. You know, n is the number of terms, a1 is the first term, and r is the common ratio. So let's go ahead and copy this formula down so we don't forget it. Find the indicated sum for each geometric series. So it's telling us it's geometric. We don't have to check. These are all yeses. These are geometric. We just got to plug it in the formula, which I'm going to skip right. Well, it's right there in the middle. Cool. Over there. There. That's a good spot. So first, we need to figure out what we're going by. Don't let these pluses confuse you. Remember, series means added up. Doesn't matter that it's a geometric series, so we're still going to add up the terms. But how do I get from 4 to 20? Well, 5 by 5. 20 times 5 is 100. 100 times 5 is 500. So R is 5. Don't let those pluses confuse you. A1 is 4. N is 14. Plug it in, plug it in. 4 times 1 minus, okay, I don't know what's that going on. Yeah, dyslexic speech. 1 minus r to the 14. 1 minus r is 5. Why did I not write 5? Sorry, guys. Yeah. Oh, yes. Oh, yes. Yes, Mom? It's late. Sorry. Type it in the calculator and let's go. 4 times 1 minus 5 raised to the 14th. And 1 minus 5 on the bottom. Holy monkey. Okay. That is our answer. Now I'm going to try and copy that. I'm just going to paste it. Screenshot it. And there we go. That's S of 14. Sure. Yay. Uh-huh. Oh. And again, we're getting really big really fast, right? We're multiplying by 5, so it's going pretty high up there. So it makes sense that we're getting a ridiculously large number that is 6, hundreds, thousands, maybe 6 billion something or another. Here we're going down. Some of these too ridiculous on this one. Looks like we're dividing by 3. Yes, yes, we are. R is 1/3. A1 is 81. And in our case, N is 20. Plug that info in and see what happens. Hopefully not as crazy as the previous one. 1 minus 1/3. Go ahead and put that in parentheses, raised to the 20. Don't forget to put the parentheses there either. Also, 2, sure. 1 minus 1/3. And parentheses don't matter, we're not doing it. Fraction. 81 times something. 1 minus 1/3. A third in parentheses all by itself. Raise to 20. Get out of that exponent and close off this parentheses right here, saying what to multiply 81 by. And on the bottom, 1 minus 1/3. And we get 121.5. Cool. All right. Next, and we're still using this formula right here. Not much to do except figure out how we get from here to here to here to here, multiplying by 2. Okay, I know A1 is 3. All right, let's figure this one out together, all right? So instead of telling us what n is, it's telling us the last number in the series, in the sequence. Series, we're doing a series. The series of the sequence. Anyway, it's telling us the last number of the sequence. Okay, we got to figure out what number it is. How many times did we go up by 2? So let's go back to this formula over here. Let's see if we can manipulate this formula. So we know AN, we know A1, we know R, we gotta figure out what N is. So plug it in and see what happens. Seriously, let's just plug it in and see what happens. So 6,144 is equal to 3 times 2 to the n minus 1 power. Now, you do know how to do this. First, we'll divide by 3. 2,048 equals 2 raised to the n minus 1 power. How do we solve exponential equations? Well, why don't you just rewrite it as a logarithm? Or you could just think about what power, that this is 2 to the 11th power, so then it's 10. But if you don't know that, write it as a logarithm. Here is our base is 2, argument is 2,048. That's got to equal n minus 1. So, yeah, logs are here. Wow. Stuff. You don't have to do this way. 11. You could just figure out 2 to what power is 2,048. So yes, don't panic. This is 11. This will get it for you. But you could also just plug in numbers in your calculator. Let's see. 2 raised to the 8th power. I need to go bigger. Let's try 12th power. Too big. 11th power. There we go. It's 2048. So once you divide by your A1, you know it's got to be this number to some nice power, because n is an integer, right? So you can just use your calculator and see what number works. You can use logarithms if you want to. It'll work. So n is 12. I said 10 earlier because I was thinking backwards. That gives me 12 is equal to n. So did I finish yet? No, not even close. Okay. Break's over. Let's go. We got all the info now. We can plug it in. Plug it in blue because I'm feeling blue with this. S sub 12. So we now know this guy's number 12. One is 3 times 1 minus 2 raised to the 12 expecting something kind of big because it's like 6,000, tens of thousands, maybe. Let's see. 1 minus 2 raised to the 12th power over 1 minus 2, 12,285. Okay, so throw it back to logarithms, or just, basic exponentials. Since we do know these must be integers. I'm going to do a new slide for this next one because, we're probably going to need some space. And we're probably going to need both these formulas. And yeah, let's just do a new slide. This guy. Let's write down what we know. A1 is 4. Easy enough. I need that. I need R. R looks to be a -3 if you ask me. -3 makes 12 times -3 is positive 36, -1. It works. Then. That's what we're going to do again. But I'm not going to bother with the logarithm. I'm just going to think about powers. But we do know that A sub n is 2,916. Has to equal. A1 is 4. R is -3. Make sure you use your freaking parentheses there. To the n minus 1 power. Divide that by 4. 729 is equal to -3 to some power. Now, here's a trick. I know it's got to be an even power because this guy's positive. So screwed up some. Nope, didn't screw up. So I'm not going to bother with things like 3 and 5. I'm going to go straight to 6. Yeah, I got it right the first try. But if you didn't get it right the first try, you could try like 4. Like, nah, that's too small. You could try like 8. Nah, that's too big. 6 is the winner chicken dinner. So this is -3 to the 6th power equals -3 to the n minus 1 power. Does that look familiar and a little bit easier? Okay, you can stop crying about logs now. Add 1 to both sides. 7 is equal to n. Beautiful. We're done. You wish. All right. We got n, we got A1, we got R. Let's plug it up in our formula here. S7 is equal to 4 times 1 minus -3. Put that freaking parenthesis on there or you fail. Raised to the n is again 7 over 1 minus -3. Or freaking fraction 1 minus -3 to the 7th power 1 minus -3. 2,188. Yeah. Kind of wide for an 8s. 7 is equal to 2,188. You might think, but wait, this guy's bigger than that. That doesn't make any sense because that's what I was thinking at first too. But let's look. This is positive, that's negative, positive, negative, positive, negative. Okay. So it makes sense that, it's a little, it could be a little bit less because we got alternating signs there. Whew. I was a little nervous there for a second. I was like, what did I screw up on? Sorry. Floor, not comfortable. Let's see what's next. Oh my God, what is this? This looks like Greek. Oh wait, it is. Remember, this is sigma notation. Same thing. But it looks like it's a little bit easier, right? Because it gives us our R. It gives us our R. Set it right there. Okay. This one gets a little fun. That's a little tricky. No, it'll work. It'll work fine. Okay. Okay. I'm ready. Are you ready? Let's do this. Here's our formula. So we got to figure out what's what up in here. So it's from 1 to 25. So from 1 to 25. Okay. So in 25. R. Well, let's look at our formula. Maybe it has something to do with this. Look, it's A1 times R to the N minus 1. Huh. So R is 2. It's got to be the thing raising the power, right? Now A1, go ahead and plug in 1 into here, you get 0. 2 to the 0 power is 1. But you would have known that if you just looked right here, it's the coefficient. So it's that number right there. A1 is 1. Plug it in. S25 equals 1 times 2 to the 25 over 1 minus 2. Plug it in. Sorry. 1 times 1 minus 2, 25, 1 minus 2 gives us that. Definitely not going to type that. I'm just going to copy and screenshot that. I'll be back in a few minutes. Let's paste this. All right, so that's S25. I'm going to pause the recording real quick, and I'll be back in a few minutes. And we're back. So let's look at the next one. Same formulas. Again, it's looking kind of like this sort of thing going on, so that's what we're going to use. A1 is negative 32, which again, you can get just by plugging in 1. We're starting into here, 0. Everything 0 power is 1. 1 times negative 32 is negative 32. R is the thing that's being raised to power. That's negative 1/2 power. N is the last thing we need, which is 8, of course. Stopping at 8. Well, yeah. Stopping at 8 because there's 8 numbers. 1, 2, 3, 4, 5, 6, 7, 8. 8 numbers. And just a number of numbers. Plug it in. S8 equal to where we start at, 1 minus negative half to the 8 over 1 minus negative half. Let's see what the calculator says. Negative 32 times 1 minus negative a half to the 8th power. Put in right. 1 minus negative a half. And that's negative 85 over 4. Yeah, I keep writing 8s instead of s's. S of 8 equals negative 85 over 4. All right. And these numbers are getting smaller, so it should be a small sum. We start with negative 32. Well, the magnitude of them. Of course, they're getting smaller, so negatives. But it's also changing signs. See, it's negative, so it's going to be positive, negative, positive, negative, positive, negative. So it should be kind of smallish instead of this ridiculously large thing here. Here's where it gets a little more interesting. So let's figure out what A1 is. Where are we starting? To do that, I'm going to plug in 6 into this right here. Negative 4 times negative 3 to the 6 minus 1. 972, that's where we're starting. Let's go back. That formula. R, well, R is negative 3. Now here's a question. What is N? Remember, N is the number of numbers we're dealing with here, the number of terms. You might be tempted to say 14 or 20, but let's think for a second. How many numbers are there from 1 to 10? There's 10, right? But what is 10 minus 1? 9, not quite 10. You have to add the 1 to it. How many numbers are there from 1 to 2? 2. 2 minus 1 is 1. Add 1 to it. So if you subtract, that's telling you your difference. That's how many numbers you moved. But you have to include that number you started with as well. So you have to add 1 back to it. So N will be 20 minus 6, which is 14, plus 1 more, 15. There are 15 numbers. If we want to use my fingers, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That was 3 5s. That's 15. There are 15 numbers from 6 to 20. Or you could subtract and add 1. Now we got the info, let's plug it in. So S sub 15, because, well, that's how many terms there are, is equal to A1, well, 972, 1 minus negative 3 to the 15, 1 minus negative 3. $972 times 1 minus negative 3 raised to the 15th power over 1 minus Okay, sure. Oops. Sure, whatever number that is. The calculator will give it to you, just write it down. So S15 is this. Anyway, same thing on this one. And, well, let's do A1 first. Plug 2 into here. That's a half times 81. Half of 81 is 40.5. All I did was plug 2 in here for M. 2 minus 1 is 1. Half times 81 is 40.5. R is a half. And 11 minus 2 is 9, plus 1 is 10. S10. 40.5 times 1 minus a half plus whole power over 1 minus a half. Type it in. Here we have 80.920 blah 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 blah. So this one gives it to you as a decimal. You could probably get it as a fraction if we did the numerator or the denominator, but you know what? Let's just go with this decimal. Well, let's go 4 decimal places. Why not? Iterate just 2. S10 is about, not exactly because I got to round it, 80.92. Now we could get a fraction for this if we really wanted to, but good enough. Okay, here we go. So these were all our series, and now we're going to talk about infinite series. I didn't write that down anywhere. Infinite series. So as you can see, these series are not stopping. They're going on and on like the Energizer Bunny. So that's what I should have probably written it down. An infinite geometric series is just a geometric series that doesn't stop. It's the sequence is going on forever. Sometimes they'll approach a number. Sometimes they won't. If they approach a number, we say that converges. If they don't approach a certain number, they diverge. So if we look here, oh, that's all weird to cut off or whatever. If I just, that's a half, right? Let's just do this, 0.5. A half plus a fourth, that's 0.75. Throw an eighth in there, I'm going to get a calculator. Seven eighths, which is 0.875. Add a 16th. 15/16. That one looks familiar. We've done this before. 0.9375. I think at the very beginning, huh? And next, it's, you're dividing by 2 each time. 1 over 32, which is 0.96875. So this sum is getting closer and closer and closer and closer to 1. So the sum of this would equal 1. That's convergent. Let's see what happens here. Looks like we're multiplying by 2. Okay, so that's 0.5, 1.5, 3.5. This is pretty easy to add. 7.5, 15.5. The next thing we're going to have is 16, so 31.5. And as you can see, the number's just getting bigger and bigger, right? It's not coming to a certain answer. It's going up and up and up. It's going to infinity. That's called divergent. So here's how we know if it's going to converge or diverge. If r is less than 1, so if our common ratio, the absolute value, because of positive and negative, is less than 1, then it's going to be convergent. If r is greater than 1, the absolute value again, that's divergent. So here we're multiplying by 2, diverges. Here we're multiplying by half, converges. Easy enough, should be. Now to find the sum, we got this nice formula, which is even nicer than the one before. A1 times 1 over r minus 1. I said that wrong. The sum is A1 times 1 over 1 minus r. Not sure what I said the first time, but go with the second one. This is our formula. Just look at it. Beautiful, isn't it? Sorry, give me a moment to play with my pen real quick. Copy that. And now I should be able to paste it and move it around. Okay. Okay, got that because there's no way I'm going to remember that. I'm not going to computer remember it either. I'm going to give it to you. So first, let's determine if it's convergent or divergent. And if it converges, we're going to find the sum. So this is how we're going to find the sum. Let's see, what's r? Looks like we're dividing by 4, so r is a fourth. Is 1/4 less than 1? Yes, it is. This is convergent. And we're going to plug it in here to find out what the sum is. A1 is 1. 1 minus a fourth. And that gives us 4/3. So as we add all these numbers up to infinity, it'll get closer and closer and closer and closer to 4/3. All right. Let's see right here. I'm multiplying by 4, aren't I? Yep, I'm multiplying by 4. So guess what? This one is divergent. How do I know r is bigger than 1? It looks like we're getting smaller, so it should converge. Let's see what the freak we're dividing by. Well, multiplying by. 3.48 divided by 5.8 gives us 3/5. But let's say these are geometric. I think it should say they are geometric. Well, we can check. We can check. And I'm pretty sure these are going to be just. Yeah, okay. So this is going to be convergent. R is 3/5. Convergent. Wow. Convergent. That's the formula. So we're adding things up forever, so n's infinity basically, but you know. We're starting at 5.8, multiplying that by 1 over 1 minus 3/5. And that's 29/2. Say so, buddy. Let's see, again, we're going down, so this should definitely be convergent to something since it's increasing. So it's changing sign, so it's got to be negative. But again, we don't care about the sign when we're looking at convergent or divergent. We just care about the magnitude. Negative 96 divided by 128 gives me negative 3/4. And we're just going to go with, these are going to be, they got to be geometric in order for us to do this. So let's just go with, yeah, these are geometric. Unless we obviously see one that's not. So it's convergent, starting at 128, positive. So Sn is equal to 128 times 1 over 1 minus negative 3/4. 28 times 1 over 1 minus negative 3/4. That gives us 512 over 7. Okay. Keep going. 4 to go. All right, so these are all going to infinity. You see this? That's the infinity symbol. Don't forget it. So the main thing we need to know is A1 and R. We have to assume conversion on these. Let's see. Find the indicated sum. Okay. Hey, I did the homework. Determine if it's convergent or divergent. So we got to see first off, is it convergent or divergent, and then find the sum if it's convergent. So convergent, convergent, divergent, convergent. How do I know? Well, it's easy. The thing in the parentheses is R is 1/4. That's less than 1, so that's convergent. Formula A1. So we got to plug in this number into here to find out what our A1 is. Since it's 1, that's 0, so it's just -2. So anything in 0 power is 1 times -2 is -2. So the sum will equal -2 times 1 over 1 minus a fourth. -8/3. Cool. Same thing here. R is 0.8. You could write that as 8/10. You could also write that as 4/5. It's a 0.8 here. I'm just going with it. The calculator should, maybe? I don't know. We'll find out. Convert it to a fraction for us. Or a final answer. But we're starting at 1, so 7. Carry 1. 7 times 1 over 1 minus 0.8. 35. Over 1 minus 0.8 is indeed 35. I'll explain to you real quick how I did it in my head. I know that 1 minus 0.8 is 0.2, which I know is 1/5. Reciprocate 1/5, you get 5. 7 times 5 is 35. But of course, you have a calculator, so just freaking use it. Let's see the next one. R is -5/2. That's less than 1, so it's convergent, right? Wrong. The magnitude is not less than 1. 5/2 is bigger than 1. We don't care about the negative. That's divergent. All right, over here, we're going to start by plugging in 2. Well, R. Let's check and make sure first. R is -3/4. That's less than 1. The magnitude of that is 3/4. That's really less than words, whatever. So 3/4 is less than 1, so we're good. It's convergent. Find out what A1 is. Yeah. Let's just type it in. -6 times -3/4 to the, what power are we doing? 2 minus, well, 2 minus 1 is 1 to 9/2. So formula sum is equal to A1 times 1 over 1 minus R is -3/4. So that comes out to 18/7. And I do believe that's it for the geometric series. So recap real quick. We got the regular old geometric series. We got a nice formula for that. Just make sure you are able to manipulate the formulas. We got 3 formulas. We got this guy, and the one we just did with the convergent series, this one. Those are 3 formulas you'll be dealing with. Make sure you can tell if it's convergent or not by looking at the R. If R's magnitude is less than 1, that means if it's between -1 and +1, then it is convergent. If it's outside of that range, divergent. Real quick, oops, didn't want to do that. Why do I not include 1 in either one of these? Well, if R equals 1, then we don't, we're just multiplying this thing by 1 each time. Yeah, no. It's going to be the same number over and over and over again. It's going to be that number to whatever power you're doing. Anyway, that's the end. Goodbye. See you. I'll be the Zane. Whatever.